I want to do a couple of examples from your textbook problems. First, I want to do problem number 5 in your textbook. Uh, as we mentioned in the earlier chapters, when you have a problem like this, first thing you need to do is to draw a free body diagram or a small sketch. So so a person is in a kayak, starts paddling, and it accelerates from 0 to zero point 0.6 meters per second in a distance of zero point 0.4 meters. So let me draw a small sketch. So, so initial speed V naught equals 0 because start from rest, and then let's say this is x direction, which is equal to zero point 0.6 meters per second, and this distance is 0.41 meters. So this distance, is x 0.41 meters. So the question is, mass is given. Mass of the person and the kayak is 73 kilograms. So mass is 73 kilograms. The question is, what is the net force acting on the kayak? So net force, F net, that is the question. So from Newton's second law, we know F net is equal to mass times acceleration. So now we need to check mass is do we know the mass? Yes, mass is 73 kilograms. So how about acceleration? Do we know the acceleration? No, we don't have acceleration, but we can calculate the acceleration based on this initial speed, final speed, and the distance it traveled. Uh, we can calculate the acceleration. So how are we going to calculate the acceleration? We can use one of those equations we learned. Let me write a couple of equations. X equals V naught T plus X equals V naught T plus AX T square. Distance or displacement is equal to initial speed times time plus acceleration along x direction times time. And let me write another equation. V square equals V naught square plus 2AXX. So this is x direction, V naught x direction. Okay, actually this is square. Okay, so let me write another equation. We learned 4 equations. Let me write the another equation. Vx equals V naught x plus AXT. Okay, so now we need to calculate the acceleration because it's not given. We need to calculate the acceleration from the information we have. We have initial speed, final speed, and the distance it traveled. So this equation number 1 has time here and here. In this problem, nowhere in this problem talk about time, so we can't use this particular equation. Okay, How about the second equation? We know the final speed right here, 0.6 meters per second. We know the initial speed, that is 0, is given. And acceleration, we don't know. That's what we need actually. X is the distance it travels. So it looks like we can use this particular equation. How about this one? Vx, we know that 0.6. How about we know x initial speed? It's given. Acceleration along x direction, we don't know. That's what we want to calculate. How? But it has time, which means we can't even use this equation. So we ended up having just one equation we have to use. So let's use this equation. Let me write this equation here. Vx square is equal to V naught x square plus 2a x t. Actually square is here. So let me substitute these numbers into this equation. Vx equals 0.6 meters per second. V naught x equals 0 plus actually I made a mistake, so 2ax, so 2 acceleration along x direction times x equals 0.41. Okay, so if you solve for ax, you will get 0.43 meters per second square. Now you have mass, which is 73 kilograms, and also you have acceleration along x direction. This is 43 meters per second square. So multiply 0.43 with 73, you will get 32.04 newtons. So this is your final answer. Net force on the person and the kayak is 32.04. Okay, let me do another problem. Let's go to problem number 7. A 1580 kilogram mass of a car is 1580 is traveling with a speed 15 meters per second. What is the magnitude of horizontal net force? So again, you have to calculate F net, horizontal net force, so which means net force along x direction or y direction, horizontal x direction, horizontal direction. So we can draw like a free body diagram. Mass of the car is 1580 kilograms, and the direction it travels has the initial speed v naught x, because it's in x direction, horizontal direction, 15 meters per second. 15 meters per second. The question is, what is the magnitude of the net force that is required to bring the car to a halt? So you need to apply a force to bring its speed at a given time, at a given location, at 0. So you need to slow down, and at one point it will come to a complete rest. So during this time, this car has traveled a distance. Before it stopped, it traveled 50 meters. So x is 50 meters. Again, time not given. So which means we have four kinematic equations along x direction or horizontal direction. We can use one of those equations to calculate the acceleration or velocity or distance, but there's no t, the time it took to slow down the car, which means we cannot use any of those equations which has time. So, net force is mass times acceleration. So we don't know acceleration. So we can find the acceleration. Let me write the equation. Vx square equals v naught square plus 2ax. This equation doesn't have time. So therefore, Vx, x is time at this location. It's 0 because it came to a complete rest. Initial speed is 15 meters per second and square. So, and plus 2 acceleration along x direction, and it took 50 meters, it traveled 50 meters before it came to a complete halt. So if you solve for x, you get a negative answer. 15 square divided by 2 times 50. And the units is meters per second. So you get a negative acceleration, which means you get a, let me substitute that. So if you solve for this one, you get negative 2.25 meters per second square. So mass of the car is 1580 kilograms times, you get negative 2.25 meters per second. Negative 3555 Newton. So why is a negative number? Because when something is traveling, and if you want to bring down to when you stop the car, you need to apply a force opposite to it travels. So that force, basically, we have to apply brakes. We know that, therefore that force needs to be opposite to the direction it travels. Therefore this negative sign means we applying a brake, or we applying a force opposite to the direction of the car. So therefore you get a negative number.